The first 30mm shell leaves the barrel of the GAU-8 Avenger at 3,300 feet per second. It is followed by 64 more in the span of a single heartbeat. The kinetic energy of the burst, equivalent to the recoil force of a small tank, vibrates through the airframe, momentarily slowing the aircraft's forward momentum. 4,000 feet below, the sea surface erupts. The rounds penetrate. When the high-velocity depleted uranium penetrators strike the fiberglass hull of an IRGC fast attack craft, the transition from solid to plasma is near instantaneous. The water inside the boat's fuel lines and engine cooling systems flashes to steam, causing the internal hardware to detonate outward. The speedboat, which had been maneuvering at 45 miles per hour, is literally erased from the water's surface. This is the first link in a new tactical sequence, a betrayal of every expectation the Iranian Revolutionary Guard Corps had about the limitations of the U.S. Navy. The Strait of Hormuz is a 21-mile-wide choke point where the rules of traditional naval warfare do not apply. In these confined waters, the Arleigh Burke-class destroyer, a $2.2 billion masterpiece of engineering, faces a mathematical nightmare. Its AN/SPY-1D radar is designed to detect supersonic missiles at the edge of the atmosphere, but at sea level, it must contend with sea clutter, the chaotic return of radar waves bouncing off Whitecaps salt spray, and the thousands of commercial vessels that transit the Persian Gulf daily. The IRGC's swarm doctrine was built specifically to exploit this. By deploying 30, 40, or 50 small fast attack boats, they create a saturation problem. For the commander of a U.S. destroyer, the dilemma is one of logic and ROI. If the ship fires a RIM-162 ESSM, it is spending $1.1 million to destroy a boat that costs less than a used pickup truck. More importantly, every missile fired is a hole in the ship's defensive magazine. Once the vertical launch system cells are empty, the ship must leave the combat zone to reload at a specialized port. We all have that one tool in the back of the garage. Maybe it's an old 1970s Ford F-150 or a cast iron skillet your grandfather used. It doesn't have a touchscreen or a sleek design, but when the modern high-tech version breaks down because a sensor got wet, that old machine just keeps humming. That is exactly what the A-10 is for the U.S. military. It's the old reliable that the Pentagon tried to throw away 5 times, only to realize that in a real fight, the old way is sometimes the only way that works. If you've got a piece of gear at home that's older than you but still gets the job done every time, tell us what it is in the comments. We want to see the warthogs of your daily lives. The arrival of the A-10 Thunderbolt II in the Persian Gulf changed the math of the strait through a process called data integration. The A-10 does not hunt alone. High above the clutter, a P-8 Poseidon maritime patrol aircraft acts as the manager of the engagement. The P-8 Poseidon uses its APY-10 radar to map the entire swarm in high resolution. The P-8 Poseidon identifies which boats are carrying heavy machine guns and which are carrying rocket launchers. It then pushes this digital target list directly into the A-10's cockpit via Link 16. To a cold operator, this is a transition of ROI. The A-10 pilot doesn't have to spend fuel or time searching. Their tactical awareness display lights up with digital icons, each representing a specific IRGC boat. The A-10 drops from its transit altitude of 15,000 feet, descending into the envelope at 350 miles per hour. Because the A-10 is a straight-wing aircraft, it can maneuver with high agility at low speeds, allowing the pilot to maintain visual tally on multiple targets at once, something a faster jet like the F-35C Lightning II struggles to do in the cramped confines of the strait. As the A-10 levels off at 3,000 feet, the pilot selects the first weapon in the sequence, the APKWS. The APKWS is the ultimate expression of sequence logic. Instead of using a $1 million missile, the A-10 uses a 2.75-inch rocket that has been fitted with a laser guidance kit. At $22,000 per round, the APKWS is the first weapon that actually favors the U.S. in the cost-per-kill equation. The pilot paints the lead IRGC boat with the AAQ-28V4 Lightning targeting pod. A trigger pull releases the first rocket. The APKWS motor ignites, and 4 mid-body guidance fins deploy. The rocket searches for the laser energy reflecting off the target's hull. In the kinetic environment of the Strait, the IRGC boats are zigzagging to avoid fire. The APKWS guidance system lead compensates for this movement. The rocket strikes the engine transom of the lead boat with a circular error probable of less than 1 meter. The lead boat's propulsion is neutralized, causing it to veer wildly or stop dead in the water. For the IRGC, this is the first betrayed expectation. They assumed that precision was a limited resource. They didn't expect the A-10 to carry 38 of these smart rockets in its pods. By the time the third boat is hit, the swarm's formation is in total disarray. The saturation advantage is gone. The hunters have become the static targets. With the swarm disorganized, the A-10 pilot switches the master arm to gun. The pilot enters a 30-degree dive. The head-up display shows the CCIP reticle, a digital circle that tells the pilot exactly where the 30mm rounds will land, accounting for wind airspeed and the aircraft's dive angle. The GAU-8 Avenger spins up. It takes only 0.2 seconds for the 7 barrels to reach their full firing rate of 3,900 rounds per minute. The sound is a visceral mechanical roar, a sound that carries for miles over open water. A 0.7-second burst sends 45 rounds toward the second boat in the formation. Each shell is a PGU-14/B armor-piercing incendiary round. The core of the shell is a subcaliber depleted uranium penetrator. When these rounds hit the water, they create a hydrostatic shockwave. Even rounds that narrowly miss the boat create enough pressure to buckle the thin fiberglass hull from the side. The rounds that hit the boat pass through it as if it were made of paper. A 30mm round hitting a marine engine block is a study in destructive physics. The engine, made of cast iron or aluminum, cannot absorb the kinetic energy of a round traveling at Mach 3, approximately 2,300 miles per hour at sea level. The engine shatters into secondary fragmentation, which then acts as shrapnel, shredding the rest of the boat from the inside out. The A-10 pulls out of the dive, the pilot feeling 4 Gs of force as the aircraft levels off at 500 feet. The pilot doesn't bank away to return to a carrier, they simply circle. The A-10's loiter time is its greatest psychological weapon. It stays in the killing zone, its engines humming, waiting for the next target to move. There is a deep irony in why the A-10 is so effective in the maritime environment. It was originally designed in the 1970s to kill Soviet tanks on the plains of Germany. It was built to be slow, so the pilot could see the targets, and it was built to be tank-like, so it could survive being hit by anti-aircraft guns. The IRGC swarm relies on small arms and shoulder-fired missiles for defense. Against a fragile, high-speed jet, these weapons are dangerous, but the A-10 pilot sits in a 1,200-pound titanium bathtub that can withstand direct hits from 23mm explosive shells. The aircraft has redundant flight controls and engines mounted high and wide to prevent a single hit from taking out both power plants. In the strategic historian's view, the A-10 is the only aircraft in the U.S. inventory that is comfortable in the swarm's environment. It doesn't fear the small caliber defense of the IRGC. It flies directly into the heart of the swarm, ignores the machine gun fire, and delivers a volume of fire that no other platform can match. The A-10 took a problem that the $2 billion Navy destroyers couldn't solve, and solved it with a 50-year-old airframe and a $22,000 rocket. The most advanced technology is not always the most effective. Sometimes the most effective technology is the one that allows you to out-sequence the enemy's logic. As the engagement continues, the cold operator logic of the A-10 becomes even more apparent. The aircraft is carrying 1,150 rounds of 30mm ammunition. After 5 strafing runs, the pilot has only used 25% of the magazine. Contrast this with the F/A-18E Super Hornet, which carries only 500 rounds of 20mm ammunition, a lighter caliber that lacks the penetrator power of the 30mm DU rounds. The F/A-18 would have to return to the carrier to rearm after just a few minutes of combat. The A-10, however, can stay over the strait for up to 4 hours, refueling from a KC-135 Strato tanker if necessary. This persistence is what breaks the IRGC's will. They cannot wait the A-10 out. They cannot hide in the clutter because the P-8 Poseidon is still watching from 30,000 feet, updating the A-10's tactical map in real time. One by one, the remaining boats in the swarm attempt to flee back toward the Iranian coastline. But the A-10 is faster than a speedboat. It herds them. A short burst from the gun in front of a fleeing boat's bow is often enough to force a surrender or a dead stop. This revision removes the bullet points from Beat 7, expanding it into a dense tactical analysis, and adds a highly kinetic Beat 8 to describe the final suppression of the swarm. The U.S. Air Force's decision to transition the A-10 Thunderbolt II from land attack roles to maritime interdiction was a direct response to the magazine depth crisis facing the U.S. Navy. By assigning the Warthog to the Strait of Hormuz CENTCOM, essentially offloaded the burden of asymmetric defense from the fleet's apex predators. When a destroyer stays in the outer ring, its vertical launch system remains fully loaded with high-end interceptors like the RIM-162, ESSM, and RIM-66 Standard missile, ensuring that the carrier strike group is protected against sophisticated anti-ship cruise missiles. The A-10 acts as a logistical shield, allowing the Navy to save its multi-million-dollar bullets for threats that actually require them. The presence of the A-10 Thunderbolt II signals that the U.S. military has achieved a sustainable kill chain, where the cost of the interceptor is finally lower than the cost of the target. This realization fundamentally breaks the IRGC's deterrence logic, as they can no longer bank on the Navy's hesitation to engage. The sequence of detecting with the P-8 Poseidon, assigning via Link 16, and neutralizing with the APKWS creates a maritime environment where the U.S. can maintain a persistent lethal presence without depleting its strategic reserves. The engagement in the Strait of Hormuz was never truly about a mismatch in firepower. The U.S. Navy has more kinetic energy in one carrier strike group than the entire Iranian military combined. The engagement was a contest of sequence logic. For years, the Navy was trying to solve a 21st century asymmetric problem with 20th century high-end tools. They were trying to use a $2 billion destroyer to hunt $50,000 gnats, a strategy that was tactically sound but strategically suicidal. The A-10 Thunderbolt II succeeded because it was built for a different kind of war, one of attrition volume and persistence. By moving the Hog from the land to the sea, the U.S. military proved that tactical flexibility is more important than technical sophistication. The IRGC expected a Navy that was too expensive to fight. Instead, they found an Air Force that was too efficient to ignore. The betrayed expectation was that the U.S. would play by the rules of modern high-cost warfare. The A-10 threw those rules out the window. As we look at future conflicts in the South China Sea or the Red Sea, the lesson of the Warthog remains: sequence beats firepower. If you can identify the target faster, hit it cheaper, and stay over it longer, you don't need the most expensive ship in the world. You just need a plane that refuses to retire and a gun that refuses to stop. The IRGC swarms are still there. The speedboats are still fast, but the horizon is different now. The low, guttural rumble of the GAU-8 Avenger is a constant reminder that the math of the strait has changed. The gnat problem has been solved, and the solution didn't come from a laboratory or a billion-dollar defense contract. It came from the graveyard of the Cold War, proving once again that in the world of tactical combat, there is no substitute for a flying tank and a very, very deep magazine. The price of winning is the realization that our most advanced technology isn't always our most effective. Sometimes the most innovative thing a commander can do is reach back into the past and pull out a tool that was built to last, built to be seen, and built to kill everything in its path. The A-10 Thunderbolt II didn't just save the Navy's magazine depth. It restored the balance of power in the world's most dangerous waterway, and it did it all without firing a single million-dollar missile. In the end, the Warthog proved that even in the age of stealth and cyber warfare, there is still a place for 30 millimeters of direct kinetic reality.